to the lecture. My name is Sonanj Jamil and our topic is Z transform. Last time we have seen that what Z transform means and what is the formula to calculate Z transform. We saw some of the examples of Z transform. Now we are going to continue Z transform. Let's suppose we are given another example, which is x of n is equal to a power n u of n, and it can be written as x of n is equal to a power n when n is greater than or equal to 0, or it is 0 when n is less than 0. So this is the formula to transform a time domain signal to Z domain. We have seen this in the previous lecture. So applying this on the following given example, we will get what if n is equal to 0 to infinity, its magnitude is just a power n. So multiply it with z power minus n. If we take z n common and using the geometric sum series, which is if a mod is less than 1, it will become this one. Applying this on the given example, we will get the Z transform as 1 over 1 minus a over z. From here we can conclude that a mod is less than z mod. So if we plot region of convergence, which will be poles and zero plot, and region of convergence will be calculated as from here the first 0, there is only one 0, which makes the system 0, 1 point, and that is z is equal to 0. If we replace z is equal to a, we will get a pole, and after drawing a circle, what we are interested is this system will, or this transform will converge if a mod is less than z, which is the outer region of the circle. So the shaded region is the region of convergence. In this region the system will converge. It will not give us undefined answer. So let us take another example. This is slightly different from the previous one, which is in this example the signal is minus a power n u of n minus n minus 1, and it is defined as its value is a power n when n is less than 0, and it is 0 when n is greater than equal to 0. Applying Z transform formula, we will get this one. Now we are interested to transform it into geometric series sum. So just adding and subtracting 1 will not affect on the answer. So, and we know that the power of anything, if the power of anything is 0, then it will come out to be 1. So we can write this summation as n is equal to 0 to infinity a power minus 1 z whole power n, and applying the geometric sum series, we will get this equation, and in this case a mod should be greater than z mod. So the region of convergence will be inside the circle, because inside the circle the a mod is greater than z mod. So the region of convergence will be the inner part of the circle. In the previous example, we have seen that the Z transform was similar, but the region of convergence was outside the circle. In this case, region of convergence is inside circle. Here is another example. In this example, we are given two signals, composite signal, which is a combination of two signal, and just applying the same Z transform rule and calculating Z transform. In this case, what we are interested to find the region of convergence. In this case, region of convergence will be, first of all, we will calculate the individual region of convergence for both the signals. For first, we have seen that it is Z is equal to 0, 1 minus, it is Z minus 1 by 2. So it will come out to be pole at 1 by 2, and in this case pole at minus 1 by 2. So these are two region of convergence, and we have seen that whenever the signal is in the form of this, as was in the first case, A mod should be less than Z mod. So outer part of the circle will be the region of convergence. So if we want to find the region of convergence of the whole composite signal, we will take the intersection of both region of convergence that we find individually. So the resultant region of convergence will be the outer part of the greater circle. So if the example is just transformed to u of 1 by 2 n and x of n is equal to 1 by 2 n u of minus n minus 1, as in this example, then the region of convergence will be this ring, the inside part of the both circles. So the next thing is transfer function. We have seen this in detail in the previous lectures, how we can find transfer function from a difference equation. So this transfer function is basically Z transform. If we are given a difference equation, first of all we will take Z transform and then taking y of z common and x of z common from the other side and dividing output our input, we will get transfer function. So if we want to find response at any angle and we are given the transfer function, we will follow this formula. This is the multiplication sign and length of zero vectors and the length of pole vectors. Suppose we are given this pole 0 plot, and this is 0, this is pole, this is zeros, this is 0, and here is 0, here is pi by 2, here is 2, here is pi, and 3 pi by 2. So from this point to this point is the length of pole vector, and if we are finding response at 0 angle and this pole 0, the distance between this to this is another vector which is 0 vector. So in this case there are 3 0 vectors, 1, 2 and 3, and the one pole vector. Let's see an example. We are given the transfer function which is z over z minus 0.8. If we plot the pole 0 of this transfer function, we will see this is 0 at origin and 1 pole at 0.8, and the circle is unit circle whose radius is 1. So if we want to find the response at angle 0, what we'll have to do is just length of 0 vector. In this case, the length of 0 vector from this 0 to that point is 1 divided by length of pole vector, which is from this to this is just 1 minus 0.8. It will come out to be 0.2. So 1 over 0.2 comes out to be 5. In the next case, length of, we are going to find response at pi by 2. So here is again the length is just 1 and the distance between this pole to pi by 2 is just what? This hypotenuse. So we can find the length of this hypotenuse by using Pythagoras theorem, which is hypotenuse square is equal to base square plus perpendicular square. So substituting the values, the value of base is 0.8, value of perpendicular is 1. So just taking square and adding them, and after taking under root, it will come out to be 1.28. So this is 1 over 1.28, and similarly at pi and 3 by 2. So if we want to plot this, just draw the frequency axis and response at y-axis, frequency at x-axis. So at when frequency is equal to 0, its response was 5. When pi by 2, its response was 0.7815. When the frequency was just pi, it was 0.55. So if we see that this filter will be just like low pass filter, it blocks the high frequencies and allows the low frequencies to pass. So we have seen that we can design a filter if we are given the transfer function, and we can draw a filter response. So that's it for today's lecture. Thanks very much.